We're going to continue our conversation with applications of trigonometry. And one of the things I want you to remember is that I've kind of gradually brought in the concepts about different terminology that's used. We started with the angle of elevation, which is the angle that rises from the horizontal, and talked about the angle of depression, which is the angle that goes down from the horizontal. So if you need to know more about these, there are already videos made that I would advise either watching or reviewing about how this works, because these were originally brought up with right trigonometry, right angle trigonometry, but they could be used for law of sines or law of cosines, and you'll see them in those problems. Another key piece of information that I brought up was the concept of bearings, north, north, east, south, and west, but also northwest or south of southwest. That's a really important concept that can be used with the law of sines as well, but I went over it in my video for the applications of law of cosines. So in these problems, I want to bring up the concept of an angle from vertical. And that is the angle between a vertical angle, the 90-degree angle, and an object. So an example of what that looks like is here. You have a vertical, and then they'll explain something like maybe something is leaning, or maybe you need to construct a brace that has an angle, or maybe there's a wire, sometimes called a guy wire, that is attached to an antenna or something, and they'll say that that wire is this far theta away from vertical. So here's a specific example that I have. And this happens a lot. You can go outside right now and look at like a signpost on the street or a telephone pole holding up the electricity. And you'll have something like this where you have a pole that is tilting 15 degrees from vertical. So imagine, we have this pole. Here it is, and it is tilting. I'm exaggerating the tilt. And that's tilting from, here's the ground, and the vertical angle that should keep this thing straight up is right here. And that vertical angle is 90 degrees. Well, I'm going to draw it over here. Please understand that this is also 90. And so it's telling you that the pole is tilting 15 degrees from vertical, going in that direction. Always, it could be the other way around. Sometimes they're more specific, but in this, I could have drawn this exact same picture over here, by the way. So then the sun, evidently the sun is over here in this corner, right? And it's shining so that this is creating a shadow here. So there's a shadow on the ground, and that's 25 feet. Okay. The angle of elevation from wherever the person is standing. So there's a person standing over here at this point, and now they're looking at the angle of elevation from the end of the shadow right here to the top of the pole, and that's 35 degrees. So notice I'm now using the whole concept of angle of elevation, which would be here. Right? Remember, elevation rises from the horizontal, and that's 35 degrees. And so now the question is, using this trigonometry that you see, how long is the pole? It wants to know this length right here. I'm going to use a cursive L to denote length. So you can't use a right triangle because you don't have any information over here. And so you need to look at it. And when you look at it, you realize, okay, this, again, is an indirect measurement of 15 degrees from the vertical. I actually don't have enough information inside the triangle, okay? But I can easily understand the complement right here. So the complement is that this is also, of course, a right angle. So to find out what's inside here, we're going to take 90 degrees and subtract 15, giving us that this is 75 degrees. And so this angle right here is 75 degrees. It's very similar to using the angle sum theorem and some of the other problems we're looking at, but this is using the complement, where the angle sum theorem uses the supplement. So now that I know that, I can now, ironically, use the angle sum theorem to find the other angle. So that angle, I'll just, match it right here. So to find this angle here, I would take 180 degrees, subtract out the given angle of 35 degrees, and then subtract out the angle I just found, 75 degrees, and that will give me my resulting angle at the top, which comes out to 70 degrees. Now, one of the things we have to really watch out for is understanding that The trigonometry is fairly straightforward. I mean, look at their key ratio. Now that we have been able to figure it out, remember we're doing this in the law of sines chapter, so we're going to use the key ratio of 25 feet is directly across from the angle 70 degrees. So that key ratio is pretty easy to get once we have established all the different measurements and understand what the problem is saying. That's the hard part. The hard part is the geometry, and a lot of students don't have the vocabulary. That's why I've tried to build it up a little bit at a time. So once you see this problem, if I gave you this problem, be like, oh, key ratio, easy, done, right? And so what will we set that key ratio equal to? Well, we're trying to find the length of the pole. So that would be, and I'm just going to use L, right? That's going to be the length of the pole, which is a side. Notice the cursive L, and then I'm going to do sine of 35, and I'll solve it as if we've done the other problems. So just be aware that the questions that are mainly asked is how do you set it up, and that's normal. It's normal to ask those questions. It is, again, a little bit complicated. So if you're doing a problem and, for instance, you don't remember how to do the angle of depression or the angle of elevation, I would go back and look at the video on that with right angles back when the trig was a little easier. If you don't know how to do a bearing, keep in mind that that video is made with the law of cosines, but it could apply to the law of sines. It's just important to realize that I tried to build those skills up gradually. And sometimes, I didn't do a video on every single aspect. Sometimes the descriptions are just somebody is drawing a triangle based on seeing landmarks. Like you might have a triangle that's made from a tree to a house to a boat. And then you would literally just label that T, H, and B and go back to geometry when they say the angle between the lighthouse, the boat, and the tree, you would label that appropriately. So I went ahead as we're talking about that, and I solved this for L. We're just going to type that into Desmos. So I come over to Desmos, make sure it's in degree mode, and I type in 25 sine of 35. And then here I will divide that by sine of 70. And you get that L is 15.259. We're talking about a real life problem, so this feet really matters. And it's also important, does that length make sense in the real world? Well, if we think about this thing in the real world, the shadow is 25 feet, so the pole, it makes sense, would be less than that, because shadows, if the sun is behind, are going to be longer. But if this came out to like 500 feet, double check. Maybe you had it radian mode. Maybe you have the key ratio wrong. Maybe you multiply by the wrong thing. Again, the trig isn't so hard. It's setting it up. So maybe spend some time rewatching some of those videos just to get yourself acquainted with the language.